Hi everyone, welcome to my Excel final project for Professor Wheeler's CIS 9467 class. In this project, I'm going to use Excel solver function, data table function, as well as other Excel functions to create a business model that other business can use it to find the best solution to their questions. The example I'm going to use for this project is an ice cream shop. The name of the ice cream shop is Zero's Ice Cream. It's actually owned by my cousin. And for this project, I'm going to mainly talk about how to find the break-even point and how to maximize net income using the financial number that we have from other business examples. And for this project, I get the third quarter income statement from my cousin, and most of the numbers here, they are just estimations. So the income statement I have here has three main components. The first component is the revenue, the second one is the expenses, the third one is the net income. The revenue is calculated by unit price times the days of operation, and then times by the units sold per day. And the expense section has two subsections. The first one is the variable cost, which depends on the number of units sold, and the days of operation because it's a wages payout every day. And the second subsection of expense is the fixed cost. The numbers here will remain the same, no matter how many units that we sold for any days. And the third part's net income, it's simply the total revenue minus the total expense. And there's also a financial ratio down here called the profit margin, which is calculated by the net income divided by the total revenue. It measures how well a business was able to create its income from the revenue that I generated. And also, there are two concepts that I want to introduce. The first one is the demand curve. So since our variable include the unit price and the days of operation, so as we increase the price, we expect there are less customers, so there are less units sold per day. And also, as we increase the days of operation, we expect the wage expense to go up. And that's all the basic concepts to understand this business model. Then I'm going to talk about the Excel functions that I use to analyze this model. So there are two useful micro stuff that I use here. The first one was used to change the unit price. I set the current value to be 7, with the minimum being 5 and the maximum being 11. And every click, you're going to either increase it or decrease it by $1, which is the cell D4 here. And the second micro is actually used to change the days of operation. The current value is 80, and the minimal value is 60 days, and the maximum value is 92 days. Every time you change it, it's either increased or decreased by 8 days, and it's linked to cell 5. So the first thing I did here is that I created two data tables. The first one is one variable with only the price. The second one has two variables with both the price and the days of operation. And according to the conditional formatting here, we can tell that the red color means that there are worse net income, which is a loss, and the green means that there are higher net income. And in order to achieve higher net income, our unit price should be somewhere around $8. And when we also account into the days of operation, we can tell that we need to work 92 days and set the price around $8 as well to achieve the highest net income. Going back to the conditional formatting, there is a manage rules option. We click into the first one, we can see that all the numbers between 30,000 and 0 are highlighted by yellow. All the numbers higher than 30,000 are highlighted by green, and all the numbers that's below 0 are highlighted by red. And also, I have a column spark lines here indicating how the net income is changing based on the price and the days of operation. As we can see here, if we put the unit price to be 5, as we have more days of operation, we actually have less net income and have a bigger loss. But for the rest of them, as we have more days of operation, the loss is getting smaller or our income is getting higher, except at the end, we still have higher loss due to a lower demand. And also, when I was creating the data table using the wave analysis, I remember that in the class we had to hide the cells and hide the formulas. And these formulas equal to the values in the total revenue, total expense, and net income. We just change the format to the symbol here so that we don't see it in the sheet. So let's go to the solver page. In the solver page, it's pretty much the same. I have the macro buttons here as well. By changing the macro buttons, the numbers here will change as well. So let's find the break-even point and the maximizing profit point using solver. First, I want to find the break-even point, which is the cell D20F. It should be equal to the value of 0 by changing the cell D4 and D5, including all the constraints here. But also, I want to make sure that there's only one result that I want, because there are many combinations in order to reach the break-even point. So I want to make sure that what's the break-even point if I only want to work for 60 days. So I'm adding another constraint. And then just using solver, I find out that if I want to reach break-even point and only work 60 days, the unit price should be $6.30. And what if I want to find the maximizing profit? Then I go to solver again, removing the 60 days constraint, and then maximize cell D20F. And here I will find that I need to work 92 days and the unit price should be $8.19 for the best demand. And here my profit margin will reach 17%. Even if you have a small business of your own, you can still use this model, just changing all the numbers in the income statement and then changing all the account names and just import all your data and you can still perform the same action here. And I hope my presentation was useful to you and thank you very much for watching.